So I'm talking about digitizing the connection between supply and demand, bringing the gig economy to the marketplace for custom parts and the technical implications of that. So design is digital, manufacturing is digital. There's been several, CAD software has been around for decades, but some of the recent innovations involve bringing it into the cloud with tools like Onshape or Autodesk Fusion 360, and adding collaborative tools to CAD design. Manufacturing is digital. We have 3D printing, new technologies coming out all the time. Even CNC machining has been around for a while, is also digital. But the process of connecting the designers, the engineers, and the manufacturers, the process of procurement is analog. A typical process of procuring a custom part is you request your quotes, send them to manufacturing facilities, machine shops, and then you wait. And then after a few hours, days, or even a week, you hear, well, your design can't be made quite exactly as it is. So please update. Maybe there's square corners or thin gaps or walls or unreachable surfaces that can't be machined. So the machine shop requests that you make updates to the design. So you do that, send it, wait again. And that can go on a few times. Finally, you receive a final quote. And by the way, you could be if you want competitive bids, you're sending these RFQs to multiple facilities, going through this process with multiple facilities all at once. Receive your final quotes and compare offers, and finally place your order. And all of this adds days or weeks to the product development lifecycle. And one of the effects for the demand side is price opacity, particularly with technologies like CNC machining. When you get your quotes back from your multiple shops, they could range quite a bit for reasons that might be mysterious at the time. But every shop has varying capabilities. Some specialize in certain types of parts and are more equipped to make them more efficiently than others. They have varying capacity at the time. If they have excess capacity, they may be willing to do it for less. Whereas if they are full, they are going to charge more. And then there's some element of human error. And these all can add up to a very large range of prices. And this is all despite abundant capacity. There are 190,000 small manufacturers in the United States, according to the National Association of Manufacturers. And they are, part of the effect for them of this inefficient marketplace is that they're siloed within their local markets. If you Google machine shop, Google pulls up a map. They assume you want a local business, right? So these businesses are only connecting with local engineers, local engineering companies, and they may even be beholden to the industry that is dominant in their region. So if you're in West Virginia and the coal business is suffering, then you may be suffering as well. So the result is that winning work is uncertain. When you send your quotes to these multiple shops, you're only going to accept that bid from one of them. The rest of them went through that process with you of giving you feedback and creating that quote, and then they didn't win the work. So the solution is technology. The technology solution is bringing the gig economy to the marketplace for custom parts. And that's going to require a lot more than some of the other gig economy marketplaces. It requires technologies of computational geometry and machine learning. So here's some gig economy brands that we're all familiar with. The gig economy is all about instantly connecting supply and demand. So I've used a lot of these, I think all of them, but TaskRabbit. Maybe when the baby comes, I'll be using TaskRabbit. But let's pause for a minute and talk about the pricing of each of these. So for Instacart and Postmates, they set basically a static price or a fraction of the underlying food that they're delivering. For TaskRabbit, I believe Tasker sets the price. Airbnb uses machine learning to recommend a price for your spare room, but ultimately the host sets the price. And Uber, among these, Uber is really the only one who sets the price for both the rider and the driver. But when you think about it, Uber pricing a ride from point A to point B is a relatively simple commodity. You have miles, traffic, weather, et cetera. That's not true for custom parts. So to price a custom part, you need to understand the geometry in depth. And there's a term called design for manufacturability. Means, can this part even be made? Right? It's pretty easy to design a part that can't even be made in CAD software. For instance, if it has confined hollows or has unreachable surfaces, it can't be machined with straight tools. So instantly connecting supply and demand requires detecting all of those cases and how they impact the price. And here's an example. This is very, very common. An internal square corner. So it's very easy in your CAD software to create two planes, join them together, and you've got a square corner. But if you want to make this with CNC machining, all of those cavities are carved out with tools that are round. So if your application truly requires that square corner, you need a very special process. You need some specialized equipment called a RAM EDM to carve it out, and that drives the price up dramatically. And not every engineer knows that when they first start designing parts. So this understanding of geometry needs to be coupled with machine learning to automatically price a part based on marketplace data. So schematically, given a history of prices that have been accepted and rejected from the demand side, from the customer side, and a history of prices that have been accepted and rejected from the supply side, from the machine shops, small manufacturers, along with all of the geometric data, specification for every part. It's a very large, complex, multidimensional data space. You can use machine learning to find the ideal price for a new custom part, given its CAD model and all of the geometric data you can extract from it, and all of the specifications of material, surface finish, tolerances, et cetera. It's a lot harder than pricing, delivering a burrito, for instance. So this is very, very powerful for for an engineer designing a part. Imagine that you could get this price within your CAD software. As you are designing the part, you see that this part is going to cost you $2,000. And you get a recommendation to add a fillet to those square corners to reduce the price. So now, instead of the tedious process of thinking you're done with your design, sending it to the shops, getting that feedback, waiting, sending it back, waiting again, that is merged into the process of design where it really belongs. So understanding how your design impacts price, getting that feedback right away is extremely powerful. And then you should be able to place your order directly from CAD software. Update your design, see how it reduces your price, and place the order directly from CAD software, as easily as ordering an Uber. From a machine shop's perspective, you should be able to see jobs available consistently online with a price given to you that you can accept. If you press that accept button, you will get that job. There's no going back and forth with the customer. There's no uncertainty in winning the work. You download the file, make the part, ship it, and you get paid. So your business is much more predictable. And the final outcome is that we've instantly connected supply and demand nationally. Every small machine shop, every manufacturer can find customers from all over the country, and the customers find machine shops that are ideally suited for creating their custom part. So instead of taking a chance on just 3 that you will find the best price, if you can source that to many, many more at once, you have a much better chance of finding the best price for your part. Thank you very much.